Good morning. Today we are doing lesson 1.4, statements of logic. How logical are you? All right, a little bit of vocabulary. So a declarative statement, I don't have a definition, but I have an example. It's simply declaring something. My example, two straight angles are congruent. All right, a conditional statement, it uses if something, 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 then something, something, something. So our example, I've taken our declarative statement and turned it into a conditional statement. If two angles are straight angles, then they are congruent. All right, so here's our same conditional statement. So if we take it apart, you remember this from science, the hypothesis is if two angles are straight angles. So that's what you're thinking about. If they're both straight angles, then they must be congruent. So that is my conclusion. And this is the symbol that we use. P would be the hypothesis, Q is the conclusion, and that little double arrow. All right, negation. This is the statement, not P. And you see I have that little squiggly in front of the P, that's the symbol. So if the statement is, it is raining, negation is, it is not raining. Okay, so we have three forms that we want to look at. The converse, the inverse, and the contrapositive. So I listed first the conditional statement is simply if P, then Q. So we're going to base it off of our original conditional statement. So the converse would be if Q, then P. We'll see an example in a moment. So you see I just switched the Q and the P. My inverse, if not P, then not Q. If not P, then not Q. And then the contrapositive, if not Q, then not P. So this right here, you might want to put a box around it or highlight it, because you're going to refer back to these three statements right here in order to change your conditional statement. So mark it in some form or fashion, put a big square around it, highlight it, whatever works best for you. All right, so let's do an example. So here's our conditional statement. So go ahead and write that down. If you live in Atlanta, then you live in Georgia. So living in Atlanta is our P, living in Georgia is our Q. So let's do the converse. Remember, the converse is if Q, then P. So Q is Georgia. If you live in Georgia, then you live in Atlanta. All right, then we go to the inverse. Remember, the inverse is if not P, then not Q. So that means if you don't live in Atlanta, then you don't live in Georgia. And we'll talk about the truthfulness of these in a few minutes. So then the contrapositive, if not Q, then not P. If you don't live in Georgia, then you don't live in Atlanta. As you can see, not all of the statements will still be true. We've written the statements according to the rule, but we know they're not all true. Obviously, you can live in Georgia and live someplace other than Atlanta, because we all live in Kennesaw and Acworth. You don't have to live in Atlanta, and then you can still live in Georgia. But if you don't live in Georgia, then you don't live in Atlanta. All right, so here's the theorem. If a conditional statement is true, that's your original statement, then the contrapositive of the statement is also true. So if P then Q is true, then that means that if not Q, then not P is also true. All right, now we're going to talk about chains of reasoning. Proofs will have a series of steps in a logical sequence. The steps could look like this. So jot this down. If P, then Q, and if Q, then R, then P, if P, then R. So here's an example with some numbers. Okay, we could say if four plus 1 equals 5, and 5 equals 3 plus 2. You can tell this is hard to write with. Then we can say, because 4 plus 1 is my P, 5 is my Q. 5 is my Q, 3 plus 2 is R. So I can say 4 plus 1 equals 3 plus 2. So that is basically what that's saying, okay? Oops. This is the chain rule. A series of conditional statements so connected is known as a chain of reasoning. So I'll give you a minute to write that down. Okay, here's an example. All right, if you study hard, then you'll earn a good grade. P is studying hard, Q is earning a good grade. If P, then Q. If you earn a good grade, then your family will be happy. So earning a good grade is our Q. That means your family being happy is our R. We can conclude if you study hard, then your family will be happy. So So our chain of reasoning led us, if P, then R. If you study hard, then your family will be happy. All right, we're going to try a couple practice problems. Okay, so we want to write the converse, the inverse, and the contrapositive of this statement. So write down your statement. If two angles are right angles, then they are congruent. All right, I'm going to give you a few seconds. I put down in the bottom corner, but it should also be in your notes. Remember, I told you to highlight it or put a square around it or something. So write down your converse. If Q, then P. And if you want to pause this for a moment and write it, then you can do that. Okay, here is our answer. If two angles are congruent, then they are right angles. All right, now write the inverse. If not P, then not Q. If you need to pause, you can. Okay, here we go. Oh, I'm sorry. I made a statement here. The converse is false because two angles could be 60 degrees. They don't have to be right angles. They could be any amount. All right, now our inverse. If two angles are not right angles, then they are not congruent. So is that true or false? Well, that's false because, again, the two angles could be 60 degrees. They don't have to be right angles to be congruent. They could be any two angles of the same measure. Okay, go ahead and write your contrapositive. If not Q, then not P. You can pause if you need to. Okay, here's our answer. Contrapositive. If two angles are not congruent, then they are not right angles. So this is a true statement because they're both saying the same thing. So we're going to practice writing the three forms, converse, inverse, and contrapositive, and you need to think about whether it's false or true. Remember that if the conditional is true, the contrapositive should also be true. That was in our theorem. If a conditional statement is true, then the contrapositive of the statement is also true. Okay? And you know, if you didn't highlight that, you need to go back and do that as well. All right, here is another practice problem. So this is for our chains of reasoning. We're going to draw a conclusion from the following statements using symbols. Now, you don't have to always use P's and Q's. You can use whatever letters that you want. So I'm going to show you the first one. If gremlins grow grapes, I know this sounds crazy, then elves eat earthworms. Oh my goodness. So for that, I put G for gremlins and E for elves. Okay? So your next statement or your next conditional statement, write down your symbols. If trolls don't tell tales, then wizards weave willows. So write down what you think that would be. I'm going to use T for trolls and W for wizards. Remember, the first part says trolls don't tell tales, so that's negated. So it's not T. If not T, then W. All right, go to the third one. If trolls tell tales, then elves don't eat earthworms. I don't like that elves are eating earthworms in this. Okay, so we have our T for trolls and our E for elves. All right, so you should have had if T, then not E. All right, so we need to connect the three of these together so that it's in a chain. but there's only one G, there's only one W. There's an E and a not E, and there's a T and a not T. So we need to go to our theorem. If a conditional statement is true, and all of these are supposed to be true, then the contrapositive of the statement is also true. So for the contrapositive, we switch the letters left and right, and we switch the negate signs. So think about which one do you think we should switch? All right, I chose, oops, I put that down. Here we go. I switched this one, so the E and T switch places. Now I have if E, then not T. So if you look, I can put the if G, then E. You see what that connects to? If E, then not T. And then if not T, then W. So therefore we have if G, then W. Therefore, if gremlins grow grapes, then wizards weave willows. That's sort of interesting. So anyway, you don't have to use P's and Q's. You can use whatever letters you want as long as you're consistent throughout your problem. And then if you see that they're not connecting, pretty much because there's the not negating sign in there, then you need to remember your theorem and switch one of them around. I tried switching the second one. That would have been if not W, then T, but that didn't work out. So you can switch a couple until you figure out which one is going to work, okay? So if you need to go through this slide again, then do it one more time to see how it goes. All right, we're going to try the homework practice. So go to your assignment tab, start working on your problems. We'll come back here in about 10 minutes to see how you're doing and answer questions. And for this one, do not do problem 13. Yeah, I thought that was just a crazy problem. So we're just going to not do it. Okay? All right, good luck, folks, and I'll see you about 10 minutes. Toodles.